Today I'll be sharing with you about the introduction of diaphragm valve. You can see it here. How can you see my mouse? Yeah, okay. So on the right bottom, that is the diaphragm valve. Okay, so diaphragm valve, basically diaphragm valve is a linear motion valve. Basically, usually when we say valve, we will ask what is a valve type or what is a valve motion. We have a rotary and linear. So for diaphragm valve, it's a linear motion valve. We will use to start stop, or we so-called on off, or regulate fluid flow, or we so-called control modulating. So basically it is suitable to be used on both on off and modulating control. Diaphragm valve, why from the name itself, why it's called diaphragm valve? Because it's using a flexible diaphragm which will be connected to a compressor. Okay, this compressor is not the compressor equipment. I will show to you later that is actually a component which is named as compressor. So the diaphragm is connected to the compressor, and it's actually the diaphragm is molded into the shape of the compressor, which is in order to function. I will show to you all later. The diaphragm is pushed into the contact with bottom of the valve body to provide shut off or lift off the bottom until flow can pass through. The visual I will show to you later again. Yeah, but this is the introduction. To control pressure drop through the valve, the hand wheel is turned until the desired amount of media is flowing through the system. Okay, to look into more detail, sorry, let me move myself a little bit. Okay, so you can see here on the right hand side. So if you notice, there's actually two types of the diaphragm valve. One is a weir type, another one is the straight through type. From the top itself, basically from the component, it has both. I'm showing with the hand view. So there's a indicator cap, there O-ring to install the indicator cap. There's a hex socket, grub screw, indicator, starboard and nut, bonnet. So you can notice the construction for both is very similar. They have the stem, and now you can see the difference. It's actually different on the compressor and also the diaphragm. If you notice, the shape of the compressor and the diaphragm is different. And at the bottom, there's a stud, body lining, and body. So the differences among these two designs are basically on the compressor, the shape of the compressor, and of course the diaphragm, because the diaphragm has to be accordance to the compressor design and as well to the body. Yeah, let me see. Okay, good. Diaphragm ni teringat belajar pasal baru-baru dalam subject science. Yeah. What is a common material to be used for diaphragm? Yeah, Wai Chong, I will show to you all later. How is it differ from pressure regulator valve? I believe what Shakib is trying to mention is the self-acting pressure regulator. Okay. So it's basically answering to the question from Shakib is basically very different from self-acting pressure regulator, because self-acting pressure regulator is from the name itself is a self-acting. According if you are trying to control on the if you are using for pressure reduction, means you want to control on the downstream pressure, or if you're using the back pressure, you want to control on the upstream pressure. For this diaphragm valve is used to the diaphragm itself or the lining itself is the sealing material. And there's a reason it's called it's been called on the diaphragm valve. Okay, so this is a type of the weir type diaphragm valve. So if you notice on the left here, there's a closed position and open position, and I have attached animation. So when the valve is closed, the medium unable to pass through. So when the compressor is lifted together with the diaphragm, yeah, then the medium can pass through. So in this design, you may notice that actually for this weir design is a very popular design, which is a very, I can say is a very, because for this diaphragm valve is actually a very economical valve. So it's widely been used in the general use application, also for the corrosive and also the abrasive services. For this design, it's suitable to be used to control the small flow, because if you notice, there's actually a raised lip, yeah, which is on the raised lip, which is the diaphragm will become used to contact with the raised lip. So the advantages of this design is because the diaphragm doesn't require to stretch or travel as far. So what we need to use, or the material have, the diaphragm material has to be used is very small or very minimal. Okay, for this design, I would say most you can find it is been using in the food processing application. Okay, so you see on the next type, this is the straight through type. Okay, so you may notice at the waft body comparing to the earlier one, the bottom of the waft body is a straight type. This one is actually there's a raised lip on the waft body. For the straight through type, is actually flat at the bottom. Okay, yeah. So the differences is like I mentioned just now, the main differences is on the component of the compressor, on the diaphragm shape, and also on the body. So for this straight through construction, it has a flat bottom, which I mentioned just now, which is in parallel, so there will be a less friction for the flow stream. So, but however, for this design, you have to use a very flexible diaphragm comparing to the rear type, because the rear type, the traveling or the traveling stroke for the diaphragm is very small. It's quite minimal. It's shorter or smaller comparing to this straight type. So for this straight through type, you have to use a more flexible diaphragm material so that the mechanism is flexible in order for you to push and reach to the or in contact with the bottom of the valve body. Similarly, this is suitable to be used for slurries, sludge, high viscosity fluid medium. Yeah, but however, it's not suitable for high temperature for this design. Yeah, because the stretching of the diaphragm material for the stroke length is longer. So for this design, usually is meant for the lower pressure rating and also the lower temperature range. Let me take a look a little bit. Yeah. Okay, some comment coming in. Hi, Roy. Can this valve work with fluid of low temperature cryogenic? Okay, later I will share with you the what do you call the diaphragm. Yeah, because basically diaphragm or rubber is not suitable for cryogenic, which is up to negative 196 degrees C operation. Yeah, so the answer is no. Yeah, the reason why I will show to you later. Okay, yeah, feel free to leave any comment if you have any question. Yeah, then I will come to you and attend to your question later. Yeah, so this is the position of the operation of the diaphragm valve. From the leftmost, if you notice, this is on the open position, so how the flow stream or the medium can pass through. If you are using it for the throttling in the middle, yeah, so you can see it's partially open, or partially closed lah. So the medium still can pass through, but it's trying to control, or we're trying to throttle, or we're trying to regulate the flow. And the rightmost on the position is on the full closed position, which you can see the flow path is actually obstructed and the medium is unable to flow through. Okay, so all this while I'm showing all are using the manual hand view or manual operated like this one. Yeah, so like just now okay, you can see my arrow. No, you don't see my arrow. Okay, so like yeah, you can see the transparent is actually the indicator cap. So the red color component is the hand view, and this is actually the body which are able to see the internal. But basically, this is the one we are using a manual hand view, means manual operated. And yes, we can install it with the electric motor as well. So we so-called by electric power lah. And commonly, yeah, if without a manual involvement of a manual operation or manual human interference, this is actually the pneumatic actuator type. So we can use on the sequential or control from the solenoid valve, from the command signal. So this is installed together with the pneumatic actuator. So on the left is actually using the diaphragm pneumatic actuator, diaphragm actuator coupled with diaphragm valve. Okay, so on the right hand side, this is a cylinder type of the actuator. Okay, back to the question from Roy just now. So diaphragm can be, okay, for this diaphragm valve, the diaphragm component can be made from a variety of the materials. So how can we, how can we choose on the choices of the materials depending on the medium, of course, the temperature and the pressure as well. And of course, because on this diaphragm valve now we are talking about the frequency of operation, especially the diaphragm is all the time moving according to the operation. So we need to know about the life cycle or the lifespan. Life cycle would be more appropriate. Okay. So the choices of the elastomeric highly resistant to the chemicals. So I've actually there's a very long list. I've trying to shorten out a few which is common ones. For example, on the neutral rubber, so it's suitable for the negative 10 degrees to 90 degrees. We can use it for the oils, for the fuels, or the neoprene. So slightly lower on negative 20 to 90 degree. Same thing we can use for grease, air, oil, synthetic rubber or natural rubber, or we so-called the Buna end, up to negative 40 degrees. The design temperature from negative 40 degrees to 90 degrees. For the brewing, dilute mineral acids or white on. Yeah, if your process is slightly higher, it can be withstand up to 140 degrees, suitable for the hydrocarbons. Hi, thank you, Izzy. Is there any size limitation? Yeah, from Jiachen, usually for this diaphragm valve, you'll be using for the smaller valve size. I believe I've seen about up to 12 inch. If larger, I believe there's still no problem as well. Then probably we have to go with the what they call actuated option, which is using the pneumatic, using air or electricity, electric motor, or of course, there are options for the hydraulic actuated as well, but not commonly seen. Do Turcomp supply this diaphragm valve from Lincoln Chow? Yes, of course. Yeah. So for any type of valve, Turcomp can supply. Most of it we get the inquiry of this diaphragm valve from power plant. Okay. For oil and gas, not so commonly. Okay, so the material of construction. So overall, why we choose diaphragm valve is because it's less expensive, or we so call the more economical, because only the body and the diaphragm is in contact with the system medium of the medium. So the rest of the component is actually sealed, so we can actually choosing a more how to say a more economical or cheaper. For example, we can use the body material. We can use cast iron or ductile iron. Of course, there are people choose for carbon steel as well, or even some of it for more economical option. They are using the PVC body. PVC body with the body lining. For example, same thing on the neutral Buna and neoprene, natural rubber, EPDM, PFA, PTFE. So all these, the body lining, the choices of the body lining and also the diaphragm is a component which is directly in contact, or it has to be compatible with the system media. So for the body type or the other component which is sealed from the out from this diaphragm or in contact, so we can use a more cheaper, like for example cast iron and ductile iron. Okay, any more question? Yeah, so on the application wise, diaphragm valve is why just now we mentioned is suitable to be used in the food processing industry or food processing application. Yeah, because diaphragm valve, like I mentioned just now, the contamination is very less or very minimal when because it's only in contact with diaphragm or lining. So most of the time people will choose the body lining and also the diaphragm on the diaphragm and the what do you call diaphragm and the body lining in the same material. For example, we can look back on this on this diagram. So if you notice there's a diaphragm and also on the body lining. So if you are choosing both with the compatibility to the flow medium or to the fluid, so basically these are the two parts will be in contact with the medium. So the rest of the component like the body, the bonnet, the compressor, the stems, and so on, those are actually excluded. So you only have to make sure the diaphragm and the body lining is compatible with your medium in terms of the temperature, in terms of the pressure, in terms of the chemical compatibility, then is good enough. Where were we? Okay, so on the first point, yes. So because the diaphragm is considered the cleanest valve, least likely to cause contamination with the lining. So then there's a reason is actually widely or widespread use in pharmaceutical or food processing. Just now I mentioned, yeah, pharmaceutical. I think they are very strict on the what do you call on the of course because you have to prevent from any contamination. So in food processing, water treatment, yeah. So economical valve, so basically used to throttle or we so-called the modulating control or on-off isolation or we so-called the start-stop. So used in water treatment as well, cheaper valve because they will have to use a lot. In the electronic industry or we so-called the what do you call basically on the electronic lah. So they are also a cheaper option. Pulp and paper, yeah, because just now I mentioned yes, the diaphragm valve is suitable to be used on the slurries or the sludge media. So in pulp and paper, so it's very suitable as well. If you're using some other valve type, probably it will cause the valve jam, or it's actually the trap in the bearing area, trapped in the what do you call trapped in the sitting area when it's in the motion. So this is one of the valve can be chosen or can be used on the application. So another one, okay, power industry, yeah. So like I mentioned, for us, Turcomp, most of the time we receive this type of valve is from power industry. But of course, it's not only limited. It depends on the process application. Like earlier I've mentioned, yeah, through all this valve we have introduced. What is the reason we have introduced all these different valve types? Because all the valve types are designed or has been introduced. They are having a different characteristic, different how to say the specification and the different function. For example, we have introduced the ball valve, butterfly valve, gate valve, glove valve, check valve, knife gate valve. Last week we talked about the needle valve. Yeah, upcoming. So we talk about the plug valve and so on. So different valve type, they are having a different characteristic, different properties, which is suitable for different application. So it depends on the design or the requirement of your application. So for the power industry, yeah, and also the water treatment, which we receive. But recently, we are really not so much working on the water treatment industry, and of course the high purity water system. So similar to the water system. So for this diaphragm valve is suitable to be used on the high purity water system as well, because again, so it's least likely to have a contamination because the in contact area is only on the valve diaphragm and also the valve body lining. Is if there is solid particle in the process medium, will it damage the diaphragm easily? Yeah. So yeah, of course, from Waichong. So the solid particle is depends as well, but for the diaphragm and the body lining, for example, if you use in the chemical, the PFA lining, the PTFE lining is very much suitable to be used on all these how to say on the chemical application. So the diaphragm is actually very thick as well. And for this valve, usually the requirement on the seat tightness or the seat leakage tightness is not so high. Mainly they are using for the on-off application. So it will not damage easily. I would say it still depends on the process application, on the life cycle as well. But this is one of the valve design suitable to be used for the with the uh, slurry particles, slurry medium, or you so-called the solid particles. Okay. Yeah, basically these are the brief introduction I've prepared today. If you notice that today I didn't touch about the standards, or so-called the design standard, the international standard. Okay, for this diaphragm valve, let's show something. Okay, for this diaphragm valve, if you notice on the left bottom, this design is actually on the flange end design. So the flange design, it can be up according to the ANSI standard, according to the DIN standard. But one challenge on this diaphragm valve design is so far there's no specific design standard, for example, on the face-to-face and on the construction. So it depends on the manufacturer. What is the standard for hydro test will be followed. Yeah, so Jiachen, like I mentioned just now, that is actually another challenge, which is the requirement for the seat tightness is not so high as well. Yeah, but of course, if you're according to the ANSI or ISO 5208, it can be followed as well on the API 598. Yeah, but basically, most of the time for the leakage class standard is not so stringent for this diaphragm valve. Okay, what Is the shelf life of diaphragm valve need to replace the diaphragm routinely? Yeah. So from Ivan Go is as well. The life cycle is actually depends on the material we've chosen. From these materials, actually, there can be a longer. But I just trying to pull up or lessen it up. So as well, then we actually have to look at after you select all the material, we have to look into the operating temperature and the design temperature. So how long or how lasting or what is the life cycle for the material? Then you have to be advised after reviewing in your process or your application. From Ivan Chat, if minor scratches found on diaphragm, can we use lapping to repair the diaphragm surface? The answer is no. So, but basically diaphragm is not a very expensive component. So it's recommended to be replaced instead of we do the lapping or to do the repair. Okay. Yeah, I will just wait for another 1 or 2 minutes if there are some upcoming questions coming in, which is pending. Yeah, otherwise, if you leave the question, if I'm not answered today, then actually we'll attend to you afterward as well. So basically, this is our sharing for today. And next week, we'll be talking about the introduction to plug valve. Yeah, I think this will be by my colleague Woon, and upcoming as well. Then after we introduce all the valve type, then we will talk about the material. For example, what is the selection or how is the selection for metal seated, soft seated? How do you choose the packing material? And slowly we'll get into more about the process application, which is, for example, on the liquid flow, on the gas flow, what is a cavitation, what is a flashing, and how do you want to determine which valve type, why do you need to do sizing and so on. Yeah, so those will be covered in the future or the upcoming session as well. So please stay tuned to our Turcomp lunch learning session. We'll be having this session from every Monday to Friday, 1:30 p.m. to 2 p.m. It's only a very short and brief 30 minutes. We'll try to share whatever we have. Then we'll split into a long term. So in all, except on public holiday, otherwise then we're all having this session. On Monday, we'll share about the technical. So next Monday again, we'll talk about the plug valve. Okay. Yeah, if I don't see any new questions coming in. Okay, then I will just wrap up for today. If any questions, feel free to leave it in the comment section. Then we'll come back to you again. All right. Wishing you all have a good week, great week, and bye bye. Have a nice day.